Alright, so let's go ahead and do a quick revision of this paper, the internal 2024. This was paper 1. So we start with the first question there. The question is asking us to simplify the expression here. Once you are asked to simplify, they are asking you to make the expression simple. So in our case here, what we do is we distribute the 3 here. It multiplies with the 2x and the negative 4. Then the negative 2 also will multiply with the x, and it will also multiply with the negative 1. So the only thing that you need to be careful with here is when you are multiplying with this number here, the negative is part of the number. So as you distribute, you'll be distributing a negative 2. So let's begin. What is 3 times 2x? That is a 6x. So I'll write here 6x. 3 times negative 4, we get a negative 12. Then we are done here. We go to the next one. Negative 2 times x is negative 2x, and negative 2 times negative 1 gives us a positive 2. Once we're done distributing, which is the removing of brackets, we can now go ahead and group the like terms. So the 6x and the negative 2x are like terms, so I'll put them together. So I'll say 6x minus 2x. Then the negative 12 and the positive 2 are also like terms. So I'll say negative 12 plus 2. So what is 6x minus 2x? That is 4x minus 12 plus 2 is what? Minus 10. So what you do here, since the numbers have got different signs, 12 is negative, 2 is positive, subtract the numbers. 12 minus 2 is 10. So you put the sign of the bigger number to your answer. Since 12 is bigger than 2, I'll put negative there. So 4x minus 10 is my answer. So in the exam, what you do is you come here on the answer space here. You can go ahead and write your answer as 4x minus 10. Let's go ahead and look at the next question. So the next question is saying negative 2 to the power 0 times negative 2 to the power 3. Well, the word evaluate means find the exact value of. So to find the exact value of, we are going to just work our expression to one value. So to answer this question, this is on indices. You must be familiar with some rules that are related or associated with the indices. One of the rules is a rule which says that if you have any number to the power 0, your answer will always be 1. So x to the power 0 equals 1 means that any number where x can be any number to the power 0, the value of that expression is what? 1. Another rule that you need to be familiar with as you answer this question is a rule which says that if you have x to the power negative n, then you can simplify this to 1 over x to the power n. So you will notice that this n here was actually a negative, but as soon as you write 1 over, the power becomes what? Positive. So with these two rules, we can go ahead and evaluate our problem. So the first part is negative 2 to the power 0. So clearly, using the first rule, negative 2 to the power 0 is just a 1. Because the power is 0 there. So any number to the power 0 is 1. So that is 1 times negative 2 to the power 3. This will become 1 over negative 2 to the power positive 3. So if you can clearly observe that here I've just used our two rules. So negative 2 to the power negative 3, the power is negative. Just like here we have x to the power n. So everything goes down, and the power which was negative, the 3 becomes what? Negative. So 1 times anything is just that thing. So here we are simply talking about 1 over negative 2 to the power 3. If you simplify this, it's just the same as saying 1 over negative 2 times negative 2 times negative 2. Let's just extend that line there. Okay. So what is negative 2 times negative 2? That is positive 4. Positive 4 times negative 2, that is negative 8. So our answer is 1 over negative 8. That is our answer. So you can come here on your answer space here, you write your answer as 1 over negative 8. I hope that is clear. I hope that's clear. So you must be familiar with some rules that are involved in indices. With them, it will be very easy for you to solve this question. Of course, there are many ways you can go about solving the questions, and what I've given you here is just one of those ways. So let's go on and do our next question. Our next question is on factorizing. It says factorize completely 27y squared minus 3x squared. So to factorize means you are going to look for some common factors. So the first thing that you are going to observe here is there's a number that can go into 27 and 3. Of course, there's no letter that is common. Here there's y squared, here there's x squared. So we have no common letter. Because there's no common letter, we're going to focus on the numbers. So you can clearly see that 3 can go into 27. 3 can also go into 3. So 3 is our common factor. So I'll write 3 here, open bracket. How many times does 3 go into 27? Because there are 9 times, the y squared remains there. How many times does 3 go into negative 3? There you just remain with negative x squared, because 3 and 3 divide out, you remain with the negative 1, of which if the coefficient is 1, there's no need to write it. Now, if you observe, what we have done here is factorizing. The only problem is that the factorizing we have done is not complete, because what is in the brackets can still be factorized. So let's go ahead and factorize what the expression in the bracket. So we have 3 there, open bracket. Since the y is squared and the x is squared, I can still write 9 as a square number. And I guess you guessed it already. This is 3 to the power what? 2. 3 to the power 2 is 9. So I have 3 to the power 2, y to the power 2 minus x to the power 2. So this expression now becomes, I can use the rule of indices, which says that if you have x to the power n and the y to the power n, this can be written as xy to the power n, like that. Okay, so using this rule here, I'll put this power 2 there. 3 to the power 2 y to the power 2 is just the same as me saying 3y to the power 2. So the power is put out there, minus x squared. So once I reach this stage, now I'm going to apply what we call the difference of two squares. This is a rule which states that if you have x to the power 2 minus y to the power 2, you can simplify this expression by just coming up with 2 brackets. You write x there plus y, x there minus y. Okay, so this rule is called difference of two squares. It's a way that we use to express expressions that look like that. So let's go ahead and factorize this. So we're going to assume this is our x and this is our y. So we're going to write 3 here, 2 pairs of brackets. The first one we write 3y x there, then we add, then the next one we write 3y x squared there, we subtract. So this here is actually our answer to this expression. So we have factorized this now, because there's nothing that we can factorize further here. Everything is done and dusted. So our final answer, we can come here on our answer space and write 3. Then we have 3x plus y. Sorry, my apologies there. Okay, supposed to be 3y plus x. Okay, then we have 3y minus x. So that is our answer there. So you can just fuse it into that working space. So remember, as you write your paper 1 exam, show your working. It is going to help you in case of an error. The examiner is going to award a mark or so, maybe for doing the right working for questions that have several marks. So it is important to show how you have found your answer. That is the reason why a lot of working space is left here for you to do your working. So there will be no need for you to look for a paper where you can do your working and then transfer your answer here. Everything must be done here. So remember to show your answers. The next question is saying a straight line L is represented by the equation 2x minus y equals 5. Find the gradient of the line L. Okay, so let's just jot down our line. So we have L is such that 2x minus 5 is equal to, what am I writing? Let's just do that again. So our line is L is such that 2x minus y equals 5. So it is very important to note that a standard linear equation takes the form y equals mx plus c, where c is a constant, m is the gradient. So from what we have here, all you have to do is write this line L, write the line L in the form y equals mx plus c. Once you write the line L in the form y equals mx plus c, whatever is in the position where m is here, or whatever is a coefficient of x, is actually your gradient. So let's go ahead and rearrange this expression. So we have 2x minus y equals 5. So the best thing to do here is just move this negative y to the other side. Just move this negative y to the other side and this 5 to the other side, because this is going to enable you to have y on one side of the equal sign. So if you do that, you're going to observe that you're going to have 2x, the 5 coming this side becomes negative, and the y going this side becomes positive. So now you have 2x minus 5 equals y, which is just the same as saying y equals 2x minus 5. So if you compare this, this expression that we have here, if you compare this to this one here, you're going to notice that where there's m here is where the 2 is here. You see that? So remember, m is representing the gradient. So we have the y here, the 2 which is with the m, the x, and the constant is negative 5. So from this here, we can conclude and say, therefore, our gradient is what? A positive what? 2. So you can come here on your answer space and write m equals 2. Is that okay? Yeah. So if that's okay, we can proceed and do the next question. So the next question is on sets, and the question says shade the region P intersection R complement intersection Q on the Venn diagram in the answer space. So this is the Venn diagram they've given us, and they want us to shade P intersection R complement intersection Q. Okay, so now the easiest way that we can use to shade this or find the area that we are going to shade is where we first give a number to each section of our set. So we can say let this be 1, this 2, 3, 4 there, 5, 6, 7, then out here we put 8. So once you have put all these numbers here, 1 to 8, we'll go back to our set. Forget about the shading later. We'll talk about it. Now let's just focus on the numbers. So we have P intersection R complement. Let's start with this first. Let's list set P. What is in P? So we come to our diagram here. You can see in P there's 1, 2, 4, and 5. So I'll write 1, 2, 4, 5. Close that. Then the next one, let's list R complement. So we're going to say R complement is what? Let's go back to our diagram. R complement means that from your universal set, this whole square here, from your universal set, remove everything that is in R. What is going to remain? That's what R complement means. So clearly you can see that we're going to remain with 1, 2, 3, and the 8 out here. So R complement is 1. So I'll write my 1 here, 2, 3, and 8. Now we have our P here represented by these numbers. We have our R complement represented by these numbers. Now, what is P intersection R complement? So P intersection R complement means which numbers are found in set P that are also found in set R complement. So you can clearly see that we have the 1 there and the 2 there. So these are the numbers that are found in both sets. They are found in set P. They are also found in R complement. Intersection means common elements, the elements that are found in both sets. So our P intersection R complement is 1, 2. Okay. Now the next part says we need to use P intersection R complement, which is this one, where it intersects with what? Q. So for us to know our final answer, it is important that we write down the value of the elements of Q. So Q, let's go ahead and check our set. What numbers are in Q? We have 2, 3, 5, and 6. So I'll come here and write 2, 3, 5, 6. Close that. Is that okay? So once I do this, now to finalize my work to check out where my answer is, from these two, I'm going to check when we say P intersection R complement intersection Q, we are simply saying what is found in P intersection R complement, this set here, that is also found in set what? Q. So you see P intersection R complement intersection Q is just what is found in P intersection R complement and Q. So you can clearly observe that there's a 2 here, there's also a 2 there. That is the only element that is what? Common. So we're going to write 2 as our P intersection R complement intersection Q. So once we know now that this 2 is our solution to this expression in set notation there, we are going to check our diagram out. So we are shading where there's what? Where there's 2. So now I'll come here and do what? Shade this part here, because that is all we found. So if there were 2 numbers here, would have shaded where those two numbers are. If there are three numbers, would have shaded where all those three numbers are. If there were four, just like that. So since it's just two that is appearing in our final answer, it's just two that is appearing, then we can go ahead and shade where the two is. Then that is our solution to this problem. So let's go ahead to the next question. I hope you are following. The next question is on vectors. So the question says, this is question 6. The magnitude, so bear in mind, the word magnitude means what? Length. The word magnitude means what? Length. So the magnitude of vector PQ is 20 units. Given that OP is this, 5, 0, and vector OQ is 17y, find the positive value of y. Find the positive value of y. So how do we find the positive value of y? So the first things first, we must find vector PQ, because we are not given vector PQ here. So in simple language, when they tell us that the vector OP is 5, 0 and vector OQ is 17y, what they're simply saying is that there is a point called the origin, and then there are these 2 points. There are lines here. These are vectors. Of course, they have a direction. So we are going to assume this is vector P, and we are going to assume this is vector what? Q. So if they ask you to find vector PQ, they are simply finding the line that connects those two vectors there. So for you to find vector PQ, all you have to do is find another way you are going to use to move from P here going to Q without using the direct what? Route. So all you have to do here is to find vector PQ, you must move from P. So PQ as a vector is equal to PO. You move from P to O, then you connect to Q plus C, PQ there as a vector. So this is a general formula that we are going to use here to find our vector PQ. So let's go ahead and work that out. So PQ as a vector is PO plus OQ, like that. You see that? Now, what is PO? What we are given here is OP. PO is simply the negative version of OP. So in short, since we are moving from P to O, we are moving against this arrow. We are going in the opposite direction with this arrow. We expect to have a what? A negative on our vector. So now this will become negative. What is given here is 5, 0. So we say 5, 0. Then we add. Then OQ is just the way it is given here. This is OQ. So OQ is 17y. So I'll come here and write 17 and the y there. So I'll go ahead and simplify this vector by, please don't forget the negative. I'll go ahead and simplify this vector. I'll say negative 5 plus 17. I add the top numbers. Then we have 0, which can either be negative or positive. So it's just 0 there. 0 plus y. So if you simplify this, what do we get? We get negative 5 plus 17 is what? 12. And 0 plus y is y. So this is the vector PQ. Now, when we find the vector PQ, we must now use this information that we are given here to work out the magnitude of PQ. We have to find the magnitude of what? PQ. So under vectors, you will notice that the formula for magnitude, which is the length of a line, is the magnitude of PQ, so we use these bars here to represent magnitude. The formula is x squared. Okay, let's write that better. The square root of x squared plus y squared. In this case, the x is the top number and the y is the bottom number, which just can also be written as 12, y like that. So just bear in mind that the top number is representing what? X, and the bottom number is representing the value of y. So we know the magnitude of PQ. The magnitude of PQ is given in the question. They've told us that the magnitude of PQ is what? 20. So where this magnitude PQ here, we put what? 20 is equal to, now let's replace there. Can do better. Where there's x, I put 12 squared. Don't forget to put that in brackets. Where there's y there, well, we're just going to leave it as y squared. With that, we can go ahead and then simplify this expression. We need to get rid of this root here so that we can find the value of y. So what I'll do is I'll square this side and square this side. Now what does the squaring do? Here on the other side we are going to have 20 squared, which we know that 20 squared, let me just squeeze my work here, 20 squared is what? 400 is equal to, this root will cancel with the 2, so this root and the 2 will cancel, so 12 squared is 144 plus y squared. Okay, now once we have this space here, we're going to go ahead and group the like terms, so you can clearly see that the 400 and the 144 are actually like terms. So I'll have to move the 144 to the other side so that y squared remains alone. So now, having said that, so we're going to have 400 minus 144 is equal to y squared. So what is 400 minus 144? That is a 256 equals to y squared. Now, to get the value of y, you just have to remove this 2 here. You just have to remove this 2. So how do you do that? You introduce the square root here and introduce the square root here. So what is going to happen is the square root will cancel the root, so meaning that I'll remain with the y. Then the square root of 256 is a number that you can multiply by itself to give you 256, which is what? 16. So there are 2 numbers that you can multiply to give you 256. So in most cases, we have to put a plus and minus here. Once we square root both sides, put a plus and minus here. So negative 16 and positive 16 qualify to be the value of what? Y. However, the question here has limited us because it says find the positive value of y. So we don't need the negative value of y. That's why I didn't put the plus and minus here. So the square root of 256 is 16, meaning that the value of y that we are looking for is actually 16. So let's just zoom that out so that you can see everything in one place. So we can go ahead here and write on the answer part there, we say y equals 16. Don't forget to write the word don't forget to write the word units. Oh no, there's no need to write the word units because we're not finding the magnitude. So every time you're finding the magnitude, you write the units in front here, but in our case we are not finding the magnitude. Instead, we're just finding the value of what? Y. So there's no need for you to add the magnitude there. I hope you are following and enjoying the video this far, and let's continue to the next question and see what the examiners had prepared for the guys who were writing in this particular year. So this one is on matrices. This question is on matrices. It says, given that question 7, matrix A is as given here, and matrix B is as it is given here, find the value of A to the power T. We read that as A transpose. A transpose. So in a matrix has got what we call rows there and the columns. These are the what? The columns. So if they ask you to find a transpose of a matrix, all they are asking you to do is change the rows into the columns and the columns into the what? The rows. So this row here will become a column. So instead of writing it the way it is, we would write it the other way around to go down. Then similarly, this row here will also become a column. So we're going to write 1 1 there. So that is our transpose. That is our transpose. That is a transpose of that matrix. As simple as that. So it's just a 1 mark question. You can go ahead and on your answer space here, write A transpose is 4 5 1 1 there. Okay. The next question is saying if find the value, find x if AB equals this matrix here. So AB means that A times B. So A times B means multiply this matrix times that matrix. So what we are doing here is we are going to multiply this and equate it to this matrix, because they're saying A times B is equals to this matrix here, 10 4 2 1. Let's go ahead and see what this is going to give us. So AB, we write matrix A, which is 4 5 1 1, and matrix B, which is x minus 1 1 2 0. Then we are told that this matrix is equal to this one here. So we're going to have 10 4 2 1 like that. Okay, now let us go ahead and multiply the left side of this matrix. Let's go ahead and multiply the left side of this matrix and see what it gives us. So what we are doing here is we are multiplying the row by the column. You see that? So this row will multiply with that column, and again this row will multiply with the second column. We'll do the same for the second one. This row will multiply with this column and that what? Column. So let's go ahead and see what this produces. So we're going to have 4 times x minus 1. So I'll say here 4 x minus 1 plus 5 times the number down, which you can tell me 5 times 2 is what? 10. Then we go ahead again, we multiply this times the second row. 4 times 1, it's 4, plus 5 times 0, 0. I'll close that matrix there. Then I multiply with the bottom row. 1 times x minus 1, that will be 1 multiplied by x minus 1. Let me write that. Plus 1 times 2. So there we have a what? A 2. We also multiply 1 times 1 is 1 times 1 times 0 is what? 0. So this whole 1 times 1 is 1 times 1 is 1 times 0 is 0. So this 1 times 1 is 1 times 1 is 1 times 0 is 0. So this whole 1 times 1 is 1 times 0 is 1 times 0 is 0. So this 1 times 1 is 1 times 1 is 1 times 1 is 1 times 0 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 matrix here is equal to 10, 4, 2, and 1. Now, there is no need for us to continue to simplify this matrix here. At this stage, we can work out our answer. Remember, our goal is simply to find the value of what? X. If these two matrix A times B equals that. So what we have done here, we have multiplied, we have not just simplified. Okay? So we can go ahead now and randomly and pick the values that have got X in them. For example, I can pick this and pick its corresponding value, which is the 10 there. Or I can pick this and pick its corresponding value, which is what? 2. So just equate those, because this is now equality of matrices. Equate this part to that part, or this part here to that part. Then you're going to find your answer. So I'll pick the first part here. I'll use both parts so that you see what I'm talking about. So I'll pick the first part there, which is 4x. Okay, let's just do that. So we have 4x minus 1 plus 10 is equals to 10. You see that? Then we can simplify this by distributing. We can distribute here the 4. We will distribute 4 times x is what? 4x, and 4 times negative 1 is negative 4, plus what? 10 is equals to 10. So we have 4x negative 4 plus 10 is positive 6. Negative 4 plus 10 is positive 6 is equals to what? 10. So now we're going to group the like terms here. The 4x will be here. I move this positive 6 to the other side, it becomes negative. So this is equals to 10 minus what? 6. So we have 4x is equal to 10 minus 6 is what? 4. I'll divide here by 4, here by 4. This cancels that. I remain with x is equal to 4 into 4 is 1. See that? So what you do is just go ahead and pick the part, any of these parts here where x is present. So you can pick this and equate it to the corresponding value there. Then make a simple equation and solve that. If you are not comfortable with that, you can pick the other part here. 1 times x is x minus 1. So there we have 1. If you want to use the other part, just choose 1. X minus 1 plus 2 is equals to, what is the corresponding value there? 2. 1 times x is x. 1 times negative 1 is negative 1 plus 2 is equals to 2 there. So here, you can clearly, let's just create some space. You can clearly see that if I simplify this, negative 1 plus 2, negative 1 plus 2, I will have x. Negative 1 plus 2 is just plus 1 is equals to 2. So you have x is equals to 2. I move this plus 1 to the other side, it becomes minus 1, meaning that x is equals to 2 minus 1, which is 1. So you can use this method. You can use this part here, or you can use the other part. Whichever one makes you comfortable, you still get the same answer, as we have found 1 here and the 1 here. So you can go ahead then on the answer space here and write that my value of x is actually 1. Yeah, so the value of x is actually 1. Please do not waste your time picking both parts. Just pick one. Wherever you can see x there, pick the part. As long as you do the multiplying part here, correct the multiplication of matrices. So if you're not familiar on how to multiply matrices, I'm encouraging you to spend some time to go through that before you enter the exam room. Before you enter the exam room. Let's proceed to the next question. Question 8. Question 8 says, given that 99, 92, and 85 are the first 3 terms of an arithmetic progression, find A, the 6th term. Okay, so let's write down our terms there. So we have 9, 9, 9, 2, and 8, 5 there. These are our terms. Now, here, this topic is under series and sequences. This is actually arithmetic progression. So you must familiarize yourself with some of the formulas that are used in arithmetic progression. So to find our 6th term, we need two things. The first is the first term. So the first term of the sequence is usually represented by A. So clear, you can see 99 is the first number there. So it's our first term. Then you need the common difference. The common difference is what you get when you subtract the second term minus the first term. So if you work your math there, you have actually 92 minus 99. This gives you negative 7. Negative 7 there. Good. So our common difference is negative 7. Then we can go ahead and since they're asking us for the 6th term, we can go ahead and say our n is equals to 6. Is that okay? So now we know our 3 terms: our first term, our common difference, and our nth term. With these 3, we can go ahead now and write down our formula. So Tn is equals to a plus, open bracket, n minus 1, close d. So all you have to do is just replace these numbers in the what? In the formula. Tn, n is 6, so we'll write here T6 is equal to 99 plus, where there's n we put 6 minus 1, where there's d we put negative 7. Let's go ahead and simplify that, shall we? So T6, meaning term number 6, is 99 plus, be careful here, you first work out what is in the bracket. So 6 times minus 1 is a 5, then there's a minus 7 there. So T6 is equal to 99. 5 times negative 7 is negative 35. Positive times negative, this is a negative what? 35. So if you simplify that, what does it give us? So we are looking at our value of T6 as 99 minus 35, which, if my maths is correct, we must have a 64 there. We must have a 64 there. So we can come here on the answer space and write see T6 is what? 64. What this means is that if you continue the subtracting 7 from these numbers, 99 minus 7 is 92, 92 minus 7 is 85, 85 minus 7, it will keep on giving you numbers. By the time you reach the 6th number, it is supposed to be 64. So T6 means that the 6th number in this sequence is actually 64. Are we together? Yeah, so let's proceed and work out the next question. The next question here says find the nth term. So the nth term is a formula that you are going to use to find any term in this sequence. A formula you are going to use to find any term in this sequence is what we call the nth term. So let's go ahead and work out our nth term. How do you do that? So we write our formula. The general formula for the nth term is this one here. This is the formula for the. This is the general formula for the nth term. Tn equals a plus n minus 1 d. So we go ahead here and write it down. So Tn is equals to a plus n minus 1. This should be in brackets d there. So when there's a, we put the first term. Where there's d, we put the common difference, but we're not going to put anything where there's what? N, because we're just finding the nth term. So we're saying Tn is equals to 99 plus n minus 1. Of course, where there's d there, where there's d, we are not putting a d, but we are putting a negative 7. So let's go ahead and simplify this. What do we get here? So since these are not like terms, we're going to distribute. So we have 99, negative 7 times n is negative 7n, negative 7 times negative 1 is positive what? 7. So now we can go ahead and group the like terms. We can go ahead and group the like terms. So we're going to have 99 plus 7 minus 7 what? N. Allow me to write my final answer here. So what we're going to have here is 99 plus 7 is 106. 106. So Tn is 106 minus 7n. So this formula here is called the nth term formula. So what this formula simply means is that this is the formula you can use to find any number in this sequence. For example, if you want to know the first term here where there's n here, just put a what? Just put a 1, because you are looking for the first term. So you find that you're going to have 106 minus 7 times 1. 106 minus 7 is 99. If you want the second term, here where there's n, you put 2. So 7 times 2 is 14. 106 minus 14 is what? 92. So you can go on and on. If you want to find the 6th term, for example, you can still use this formula. Where there's n here, put 6. So 107 times 6, whatever you get there, you subtract from 106. You find that the answer you're going to get will be 64. Is that okay? Yeah, so let's go ahead and check out the next question in our paper. This is question 9. So the question A says a 6-sided die is thrown once. Find the probability of getting a number which is a multiple of 3. So multiples of 3 are numbers where 3 can go in without leaving a remainder. Okay, so multiples of 3 are numbers where 3 can go in without leaving a remainder. So if you check, the first few multiples of 3 are 3, 6, 9, 12. They continue like that. But on a die, it goes only up to 6. So from this list here, how many numbers are multiples of 3 that are found on the die? It's just these 2 there. So there are how many? 2. So we can go ahead and write our answer for the first one and say probability that we are going to get a multiple of 3, okay, is equal to, there are 2 numbers there, 3 and 6 itself. So it's 2 over, how many sides does a die have? It has got how many sides? 6. So you can go ahead and simplify this. 2 into 2, 1. 2 into 6, 3. So this is our answer. So the probability there is equals to, let's just zoom that there so that we can write properly. Probability 1 over 3. There, beautiful. Yeah. Okay. Here we didn't write our Tn, so we can just go ahead and put it. So Tn is 106 minus 7n. The next question. This is an equation. So say solve the equation. So this is B. Solve the equation, open bracket, 1 minus 2t squared is equals to 25. So to solve this equation, the first thing you're going to do is just introduce the square root both sides so that you can get rid of this power 2. So here, square root, here, square root. But don't forget to put plus or minus on this side. I could write that. Okay, yeah. Don't forget to put the plus or minus. So what we are having here is this 2 cancel this root. So you remain with minus 1 minus 2t. 1 minus 2t is equal to plus or minus. What is the square root of 25? It's 5. So now we can proceed and pick these parts separately. So we have our values of t are 1 minus 2t is equals to 5, or 1 minus 2t is equals to negative 5. First, remove the root. Then, once you square root both sides, you're going to have plus or minus here. So here it's plus or minus 5. Then separate. This part is equals to the positive part, or this part is equal to the negative part. So here we just group the like terms. So I would prefer to, since the t is negative, move it that side so that it becomes positive, and then take the 5 on the other side. So we have 1 minus 5 equals to t, which is negative 4 equals to t. Divide here by 2, divide here by 2, this cancels that. You remain with, you remain with t equals to negative 2. Okay, so this is just the first value of what t. We go ahead and work out the other one. So I will do the same. I'll move this negative 2t to the other side to make it positive, meaning the negative 5 will have to come the other way around. So I'm going to have 1 plus 5. When this 5 goes the other side, it becomes positive, is equal to positive what? 2t. So 1 plus 5 is 6 equals 2t. To get the value of t, I divide by 2 both sides. This cancels that. I remain with t equals, how many times does 2 go into 6? That's a 3. So that's, or those are the values of what? T. So t is either a negative 2 or a positive what? 3. So I'll come here to my answers. I'll write t equals negative 2 or positive what? Positive 3. Okay. Yeah, so this is the answer to our equation here. These are the two answers that we get when we are solving our equation. So for now, I'm going to end here because I don't want the video to become too long, because when it's too long, it might get boring for some people. So we'll continue this video. Please watch out for the next part, which will be posted soon. As you go ahead, as you prepare for this exam, if you're writing an exam, please feel free to use this video. Go through. I'm a firm believer that from this video, you can learn a few things that can create a positive impact in your exams. Otherwise, I wish you all the best as you prepare for the exam. Keep on studying, keep on working hard. the future is bright. Thank you so much for watching this video. Bye bye.